Awesome. So I apologize for the mask and the blurred background. I'm in lab, but these are the protocols. So I want to just talk to some recent work on using indirect force control for manipulating unknown objects. And before I start, I want to say that this is joint with a graduate student here, Orion Taylor. And so we're both working with Professor Alberto Rodriguez at MIT. And so we're going to focus on this problem of manipulating unknown objects blindly. And by blind, I mean we're just using proprioception and force torque sensing at the wrist. And we think this is a good problem because it sort of embodies a lot of the challenges of controlling unknown objects, manipulating unknown objects. In particular, you can't directly observe or control all the contacts. Here you can't, oops, sorry about that. Can't observe or control directly observe or control the interaction between the object and the ground. You have limited control authority due to friction. You just have a palm, so you can only push on the object. And lastly, even in this simple system, you have sort of a diverse set of what I'm going to call contact configurations, which are sort of lead to different types of manipulations. So here you can pivot about a fixed point contact, or you can slide the object along the ground, or you can slide your hand along the object. And so we manipulate these blind objects. Instead of thinking about the center of mass trajectory of the object or the shape, we think about estimating and regulating what we call the contact configuration, which is just the location, geometry, so in this case, point or line, and mode, in this case, sticking or slipping, of all the contacts between the robot, object, and environment. This framework we've developed consists of two parts. There's something that estimates the contact configuration and something that controls it. Here, we'll sort of just focus on the controller, which given the best estimate from the estimator is going to try to regulate the object motion in admissible motion directions. So this could be the orientation of the object or its sliding motion, while maintaining the hand contact wrench to stay in the contact configuration that you're in, if that makes sense. And so to give you an example of what this means, if you think about this pivoting primitive with sticking point contact on the ground, sticking line contact at the hand, the only thing that you can change is the orientation of the object. And so you're trying to minimize some orientation error here by moving in an impedance target. So we set impedance targets for the hand, and we set them in a way such that it minimizes orientation error, subject to both the wrenches that the hand applies to the object and the ground applies to the object being within the wrench cone. So this is just maintaining that contact configuration of sticking. And the objective is somewhat straightforward. I just want to try to explain it quickly. The intuition behind it here is that you minimizing over the impedance target, change in impedance target, which is this delta x tar, and the corresponding approximation of the wrench you think you'll apply, where we relate the impedance target and the wrench just using the stiffness matrix that we use to set the impedance, the stiffness matrix in the impedance controller. And what you can do is you just minimize this error, delta theta, which is the error in orientation, by moving the impedance target along this vector v theta, which in an ideal case would correspond to the incremental motion resulting from an incremental rotation by delta theta. It can also be set naively to allow manipulation of unknown objects. And so this is what it can do. So here it's just regulating the position of the object to the upright. And you can see my colleague Orion perturbing the object back and forth, and the controller is able to recover both the pose while maintaining the contact configuration. You can do this for other primitive motions as well. So you can regulate the sliding position of the hand on the object, as well as you can regulate sort of the location of the pivot on the ground. And this is just using the robot's proprioception and force torque sensing. And obviously the estimation that I haven't talked about, but the controller that I just discussed. And that's all I had.